welcome to the podcast. This is Mr. White.
And Mr. Sapp.
And today we're going to talk about subtracting vectors versus adding vectors, which we spent a lot of time doing. So there's a lot of ways to think about this. First of all, before we added vectors.
And we just did tail to tip.
Right. We said, hey, this north vector plus this east vector gave us this resultant vector that was somewhere north and east.
Right.
Okay. So we did vector 1 plus vector 2. Subtracting is like addition. Subtracting is adding the opposite. And so we're going to refer you to page 355 of your textbook. And we're talking about this today because on roller coasters you can accelerate without changing the actual speed by simply changing the direction. So, for example, you could have an initial velocity to the right, that's vi, and you could have a final velocity that is up. And so if you wanted to know the change in the velocity, that would be vf minus vi. I would also argue that this is vf plus negative vi. So negative vi is this.
Right.
And so as a result of doing that, we'll get a slightly different look at this. And so if I had to say vf plus negative vi, I can still do tip to tail,
right,
but I just have to remember that I'm turning that original positive vector around. So it would be vf plus negative vi, and the resultant vector is somewhere over here. Yeah, see, something like this. And that is the resultant vector. So this is the change in the velocity. And so if we wanted to assign some numbers to this, we're usually a lot more comfortable with that because this is still a right triangle. And if we were to say VF was just, let's say, I'm looking on page 355. It says use the Pythagorean theorem.
So it's just giving us, it just says it's the same in both directions, so we're just using like 1.
1 and negative 1. So I'm still going to do some right triangle Pythagorean theorem stuff, and I would say, well, the VF squared plus the negative VI squared root of is going to give me the change in velocity. Now we're not used to seeing that, but since it's a right triangle, we get away with it. 1 squared plus negative 1 squared root of, and when we hack all that out with our calculator, we determine that the change in velocity is in fact 1.4 meters per second due to the change in the direction. So we weren't going right anymore, we were going up. And in order to change that, we had to have a change in velocity vector up and to the left.
Correct.
So if I were you, I would pause this, rewind a few seconds, and hear that again. Okay? So we are originally going right. In the final, we were going up. In order to make the change in velocity has to be up and to the left.
Right, just the opposite.
Okay? So kind of wrap your brain around that. See the picture, type the numbers in, see what you can do.
So that is the answer to the average acceleration.
Right. Well, it is if, so we said the change in velocity was 1.4 meters per second, and if this all took place in 1 second, then the average acceleration would be the change in over the change in, and so average acceleration is 1.4 meters per second squared. So for every second that this is happening, the velocity is changing by 1.4 meters per second up and to the left. Okay?
All right.
If you wanted to find the angle, we go back to our picture. Okay, well, we find the angle. I know side opposite. I know side adjacent. So I would say that the tan of the angle is opposite my angle over adjacent my angle. And so I do tan inverse of both of this. I get negative 45. And when I see that, I realize this is not a 45-degree angle because this is in quadrant 2 versus quadrant 1 or 4 or 3. So it's going to be negative 45 from 180. So the actual angle of the change in velocity is the negative 45 from 180. The whole thing is 135 degrees from here to here. You can see this a lot easier with just a protractor, but I can't place a protractor on the screen for you, so I do the trig method that I'm fully aware of. I believe that that's the basics of it. That's the meat of this. I guess my advice here is to draw pictures. By drawing pictures, it allows you to visualize this a whole lot easier than if you were just to try and visualize it in your brain. Write it down, take some space, scratch stuff out.
Well, you might want to draw on graph paper too if you're going to try to use a protractor. Try to get more accurate than just doing a simple sketch.
Yeah, the graph paper is nice because it does allow us to grid things out. So what we would like you to do is we'd like you to check out number 4 on page 356. It gives you some different values rather than 1, but you're still applying the Pythagorean theorem. You can still apply the average acceleration concept is over a different time interval than just 1 second. Work your way through that. I recommend that you do that and then check with us for the answer to see if you're on the right track.
Right on.
So I believe that covers it. Signing off, this is Mr. White.
And Mr. Sedler.